This preview is for evaluation only and cannot be used for public screening.
It's a journey that has lasted a century. A spacecraft approaches its destination, a planet beyond our solar system, and a future beyond our imagination. Touchdown will mark a milestone in our eternal quest to expand our horizons, to explore and survive. It's not the first time we've struck out into the void, against all odds. For much of our history, the oceans were the great unknown. Several thousand years ago, a seafaring culture emerged in the Southwest Pacific. Riding ocean and wind currents, the Polynesians sailed east, navigating by the stars, the moon, and the sun. Over centuries of time, they claimed the Pacific Ocean, island by distant island. It was one of the most expansive migrations in human history. Their furthest reach, Easter Island, over 2,000 kilometers from the nearest land. Today, we have begun to reach beyond our own planetary shores. Across distances so vast, we measure them in light years. That's how far light travels in a year, almost 10 trillion kilometers. Out in the southern skies, just over 4 light years away, you'll find our sun's nearest neighbors, a dim red dwarf star called Proxima Centauri. And a pair of sun-like stars called Alpha Centauri. Go beyond them, you've entered the local bubble. A giant, empty region cleared of gas by a star that exploded long ago. Within this bubble, 50 light years from Earth, are 150 stars bright enough to be seen with the naked eye. Nestled among them are 2,000 smaller stars, visible only with a powerful telescope. How many have planets? Could any serve as stations on our way to explore the galaxy? Our first stop could be a planet discovered in orbit around the star nearest to Earth. Proxima Centauri. One side, forever bright and warm, always faces its sun, while the other is dark and freezing. Could life flourish here? Could humans survive? The key is whether there's an atmosphere, and water on the surface.
This preview is for evaluation only and cannot be used
They
for
may be
public screening.
signs that there's a climate and temperatures moderate enough to support life. The only way to really know is to pay the planet a visit by crossing the immense void between us. To get there in the short course of a lifetime will take whole new types of spacecraft, whole new designs that can propel us to extreme speeds. On the ground, this is the ultimate. A high-performance race car can exceed 350 kilometers per hour. For all a race car's power, friction with the road and the atmosphere holds it back. One way to fight friction: soar into the upper atmosphere. The SR-71 Blackbird can top 3,500 kilometers per hour, 10 times faster than a race car. Still, a full tank buys only a few hours of flight. A Saturn V rocket is even less efficient. To rise into orbit, it hits 28,000 kilometers per hour, almost 10 times faster than a jet. But the faster it goes, the more fuel it burns, the more it has to carry. To get astronauts to the moon, a Saturn V rocket had to lug 16 times its weight in fuel. Because of the amount of fuel needed just to leave the Earth, most long-distance spacecraft can only coast to their destinations. The twin Voyager spacecraft got around this by using the pull of Jupiter's gravity as a planetary slingshot. Racing out at 62,000 kilometers per hour, more than double the speed of Saturn V, Voyager 2 became the first spacecraft to exit the solar system. But as fast as it's going, it will need another 73,000 years to reach Proxima b. To get there within a human lifetime, we'll have to reinvent the rocket. The search for faster, more advanced spacecraft began in the 1960s, in the shadow of the nuclear arms race. Nuclear bombs release energy by splitting the atom. Imagine if that potential could be harnessed to power an engine. Scientists tested a whole new type of rocket, a vehicle propelled by small nuclear explosions. They envisioned an orbiting space station as the launch pad for the Orion spacecraft. A series of controlled nuclear blasts set off behind the craft would accelerate it to 10% the speed of light. Orion would reach Proxima b in just over 4 decades. But the technology was unproven and perhaps
This
unsafe.
preview is for evaluation
Orion
only
never
and
got off the
cannot be
ground.
used for public screening.
In the 1970s, British engineers turned to another type of nuclear power: fusion. It's the energy that lights up the sun by forcing atoms together under immense heat and pressure. Their concept, a 200-meter-long craft called Daedalus. It would use fusion power to produce an extremely hot gas that would propel the craft by blasting out the back. The idea was to vault beyond the solar system, then launch a second stage that would accelerate to 12% the speed of light. But to go this fast, Daedalus had to carry more than 40,000 tons of fuel. As it flew past its target, at 129 million kilometers per hour, it would deploy a fleet of robotic explorers to go in for a quick look. Daedalus was never built, but the completeness of the design has inspired new generations of dreamers. Today, one group of scientists believes it may have a way to reach Proxima b. The concept begins with a solar-powered generating station orbiting Earth. It's lined with lasers, each aimed at a tiny spacecraft, a futuristic version of that Polynesian sailboat. The force exerted by each laser beam is small, but together, in frictionless space, they can propel a space sail with staggering success to 20% the speed of light. In just 20 years, a fleet of laser-powered kites approaches Proxima b. They send their data, bouncing from one craft to the next on a 4-year return journey to Earth. If Proxima b proves a worthy destination, there are technologies on the drawing board that promise an even faster ride. What if we could tap into the stuff of science fiction? Antimatter. It's the product of high-energy radiation that rips through our solar system. When cosmic rays smash into atoms in our upper atmosphere, they create a spray of particles of the opposite charge. If we can't capture antimatter particles in orbit, we may find a way to produce them on Earth. Antimatter is the most powerful fuel known, able to propel a spacecraft up to half the speed of light. Within the spacecraft, protons and antiprotons are isolated with magnetic fields. They're channeled in parallel to a propulsion chamber.
This preview is for evaluation only and
Where they
cannot
collide,
be used for
the
public screening.
streams annihilate each other. The blast creates a high-energy beam that pushes on a magnetic field within the craft, accelerating it forward. The amount of antimatter needed for a trip to, say, Saturn, 1,000th of a gram. Such a potent fuel brings serious hazards. The high temperatures produced by an antimatter engine would be enough to destroy the spacecraft. It would have to be made of materials not yet invented that can radiate that heat into space. Setting out on its journey, the spacecraft must navigate an obstacle course of interstellar objects. It meets a meteor with a battery of shields that pulverize the object and whisk it away. If the craft plows through a cloud of dust, it's buffered by a protective magnetic field. As it finally closes in on its target, it releases a probe, our cosmic envoy. Powered by its own antimatter engine firing in reverse, the probe will spend years, even decades, slowing down. Even at these speeds, the mission is probably too long for any human to go along. Imagine a time in the future when the stars are literally at our fingertips. A spacecraft maneuvers into an orbital station in preparation for a launch. It's a testament to science conceived on a stunning theoretical frontier, with engineering far beyond what we know today. It's based on a mind-boggling discovery by Albert Einstein that gravity is actually the warping of space by massive objects. What if a spaceship could manipulate this strange cosmic trait to pass between the folds of space and time? Such a spacecraft would run on exotic forms of matter not yet discovered, and the equivalent of all the electric power generated by the United States.
This preview is for
Welcome to Warp
evaluation
Drive.
only and cannot be used for public screening.
In theory, this ship could go faster than light as it traverses the galaxy in a cosmic bubble. Who can say what ideas or technologies will one day propel us forward? In the meantime, Proxima b and a host of other planets will be waiting. Whenever we finally do arrive, an unmanned probe will no doubt take our first peek. It might land using the same technologies we've perfected in our day, at the dawn of planetary exploration. Sensors will probe the alien landscape. Artificial intelligence will interpret what they see. The planet's soils, its atmosphere, perhaps the presence of life. Steadily, a new world will surrender its secrets. With each revelation, we'll reflect on the odyssey that brought us here, and how it began in the discoveries and dreams of generations long past.